Welcome to this explainer. Okay, today we are going to conquer polynomials together. Now, I know math can kind of feel like a foreign language sometimes, especially when we start throwing letters into our numbers. But take a deep breath. I am right here with you. I promise, by the end of this session, you're going to feel completely confident tackling these problems. We're going to take it just one step at a time, looking at the pictures before we ever worry about the formulas. So here's our quick roadmap for today. We'll kick things off with math in the real world, visualize what a zero actually is, and then work our way up through 3 levels of difficulty: linear, parabolas, and cubics, before wrapping up with a really handy cheat sheet and a pro trick. All right, section 1, math in the real world. Let's just dive right in and look at why we even care about this in the first place. Because let's be honest, nobody wants to solve equations just for the sake of it, right? So before we look at any equations at all, you should know that the exact math of polynomials actually powers everyday things all around us. You know when you see a shopping discount automatically applied in your online cart? Yep, that's polynomial algorithms at work. They're also used by engineers to measure land area, by architects to design those incredibly safe, beautiful buildings with sweeping curves, and even by telecom companies to track and predict your phone data usage. So this isn't just textbook stuff, you guys. This is literally the invisible code of the real world. Moving on to section 2, visualizing the zero concept. Let's look at what a zero actually is, purely visually, before we even think about touching any scary formulas. Please don't let the word zero intimidate you. I know when an exam asks you to find the zero, your brain might just panic and think nothingness. But in simple, friendly terms, a zero is just a physical, visible location. It is literally just the exact spot where our drawn line crosses that flat, horizontal x-axis on a graph. That's the whole shebang. It's just a crossing point. Okay, section 3, level 1, linear lines. Let's look at this together, starting with the absolute friendliest type to begin our journey. Take a look at this straight line crossing our grid. This right here is the visual shape of the formula y equals 2x plus 3. Now, before doing any math, just look at the line. Notice how it slices right through that horizontal x-axis at exactly one single point, right there between -1 and -2. And because it's a completely straight line, it can only ever cross that horizontal line once. That crossing point, that is our zero. Now, if we peek at the data table that creates this line, we can really see how the coordinates change. Notice what happens to the y values. They go from -1 up to +1 and then +3. So somewhere between -1 and +1, the y value absolutely had to be exactly 0. The magic 0 happens algebraically exactly when the height, the y value, drops all the way down to 0, so it's sitting perfectly flat on the axis. So let's solve this easy example step by step, exactly like you would on a test. Step 1, we read the question. Given the equation y equals 2x plus 3, find the 0. Step 2, identify our goal. We need to find the x value when y is absolutely 0. Step 3, we set y to 0, which gives us 0 equals 2x plus 3. And finally, step 4, we isolate x. We just move that 3 to the other side to get -3 equals 2x, divide by 2, and boom, we discover our 0 is -3/2. Notice how it perfectly matches our visual graph? See, you've already mastered level 1. All right, section 4, level 2, parabola patterns. Great job so far. If you followed that, you are right on track. Now, let's level up to our medium difficulty, quadratics. These are the ones that create those beautiful U-shapes called parabolas. Now, what is really interesting about this equation is the shape. Whenever you see an x squared in your formula, like y equals x squared minus 3x minus 4, your line is going to bend into this U shape. Look at how the smooth curve dives below the middle horizontal line and then comes back up. Because it dips and rises, it crosses the x-axis twice. We can visibly see it crossing at -1 and +4. Now, if we were to solve this step by step, we'd identify our goal, factor x squared minus 3x minus 4, we break it down into x minus 4 times x plus 1, set that whole thing to 0, and exactly as our graph shows, our zeros are +4 and -1. Pretty cool, right? And this brilliantly illustrates a super common student mistake. When exams ask for zeros, a lot of students just assume every single equation has to have one. But remember, a parabola is kind of like a bouncy ball. It might cross the x-axis twice, like in the first image. It might just bounce and touch it exactly once, giving you only one zero. Or, as we see in case 3,
it might float completely above or below the x-axis, never actually touching it at all. And in that case, 0 zeros. So always trust the visual shape first. Moving right along to Section 5, Level 3, Complex Cubic Curves. Take a deep breath. You are doing absolutely great. We've conquered straight lines and U-shapes, and we are now ready to tackle a hard board exam level concept. So, when your equation has an x to the power of 3, it's called a cubic polynomial. Let's look at y equals x cubed minus 4x. This cubic equation creates this really elegant sweeping S-curve. Let's identify our goal. Solve x cubed minus 4x equals 0. Step by step, we factor out an x, which leaves us with x times the quantity x squared minus 4. Then we factor that further into x times x minus 2 times x plus 2. We set them to 0, and we get our three zeros. 0, positive 2, and negative 2, which is exactly where it visibly weaves right through the axis. But just like before, you've got to watch out for the examiner's trick here. A cubic polynomial has at most 3 zeros. Depending on how tight those curves are, it might not actually cross 3 times. On the left, you can see y equals x cubed just flattens out and crosses exactly once, right at 0. On the right, y equals x cubed minus x squared loops just enough to touch the axis and cross it, giving us exactly 2 zeros at 0 and 1. Remember, you're really just counting the crossing points. Okay, we've made it to Section 6, Cheat Sheet and Pro Trick. You've officially made it through the absolute hardest part of this topic. Seriously, I'm so proud of you. Let's lock in this knowledge with a simple cheat sheet, and I'll show you a surprise shortcut for your exams. So here is your 5-point cheat sheet to memorize. Point 1, linear lines, which have a highest power of 1, have a max of 1 zero. Point 2, quadratics, with a power of 2, max 2 zeros. Point 3, cubics, power of 3, max 3 zeros. Point 4, whatever your highest power or degree is, that is your maximum number of zeros. And finally, point 5, the ultimate mistake check. Please, please always remember to look for where the line crosses the horizontal x-axis, never the vertical y-axis. But here's a question for you to think about. When you're sitting in a quiet exam hall and the clock is ticking and you're stressed, do you actually have to get out a ruler and carefully draw these complex, swooping graphs every single time a question asks you to find the zeros? Well, the crucial point here is this surprise trick. No, you absolutely do not. You can skip the drawing completely. Because we know that the 0 is just when the entire equation equals nothing, you can solve the algebra directly. Look at the quadratic example here. Given q of y equals y squared minus 1, instead of drawing it, just set the whole thing to 0. Y squared minus 1 equals 0. Move the 1 over so y squared equals 1. And what numbers squared equal 1? Positive 1 and negative 1. Boom! You instantly found your 2 zeros without drawing a single line. Visualizing helps us understand why it works, but the algebra, that's your fast track how. To wrap up, just keep the fundamental theorem of algebra in your back pocket. Your polynomial's highest degree, or its highest power, tells you exactly how many zeros to hunt for at a maximum. You've gone from basic lines to sweeping cubic curves today, and you've seen both the visual beauty and the algebraic shortcuts behind them. So take this newfound confidence with you. What level of math are you ready to conquer next? Thanks so much for joining me on this explainer, and I'll catch you next.